IME Technologies develops and manufactures electrospinning equipment for research and the production of nanofibers. Nanofibers are nothing more than extremely thin polymer fibers, and they are produced via a technique that we call electrospinning. Electrospinning in its basic form is a simple process, but it has a wide range of possible applications, and there are numerous factors that influence the process. And in order to deal with that, IME Technologies has developed high-quality electrospinning equipment that rules out all the disturbing factors and influences and offers the user complete control over all the process parameters in order to get the same output over and over again. You use a polymer that you liquefy by adding a solvent to it, and that solved or liquefied polymer is ejected through a very small injection needle or a nozzle. And by means of an electric field, we draw an extremely thin fiber out of the droplet of solved polymer towards a collector, which can be a stationary plate or a rotating mandrel, on which we finally collect that polymer fiber. One of the most interesting applications of electrospun material is that in the biomedical industry. Electrospun membranes can be used as scaffolds for tissue engineering, for instance for growing human body parts like arteries and veins, windpipes, or even a complete heart valve. But you can also think about wound dressing applications or drug delivery technology, in which electrospun nanofibers can be made of good use.
Probably everybody of you have seen the patient. She's a wonderful girl that unfortunately has had a car accident during the 6 months of pregnancy, for which, among other things, she has a complete transected airway. So tomorrow we plan to do the first in human ever done laryngotracheal transplants using bioartificial scaffolds.
With this material we think that cells are better at home in their environment. They can create the right type of tissue so that we have a real integration of the tissue into the body rather than an encapsulation by fibrous tissue.
So we take these CAT scans, CT scans of the patient's neck. From the dimensions, we make this replica in plastic, the exact replica of the patient's windpipe or trachea. And the stem cells are seeded, almost rained down on top of the scaffold inside the bioreactor.
We have several applications for this type of material. There's also the strength of this technology. We can adapt our material to different applications. One type of implant that is used now is giving quite some problems in healthcare. It's a very big issue the last few years. And with this material we hope to have a more friendly, patient-friendly type of material that lasts longer, so that we do not come into the problems with complications that we've seen before.
Und wir glauben, dass es in naher Zukunft möglich sein wird, Patienten maßgeschneiderte Organe zur Verfügung zu stellen.
The technology is developing very quickly, and indeed the most materials that can be spun by this type of technology is already available. So the issue is now to show that cells can do the thing that we want to do. We should show biocompatibility. We really hope to get into the clinic in about 3 years from now.
IME Technology now delivers universal and versatile R&D electrospinning equipment for doing basic electrospinning research and product development. Customers can do their product development completely on their own, or IME Technologies can assist them in the whole process from first proof of principle testing until the complete development and engineering of the production process of the end product. This development will finally lead to also an end product that has to be produced. Also therefore IME is working on bigger production scale systems for electrospinning production. And also if we take into account the biomedical products, clinical production has to be incorporated into the complete machine development.
Materials will come and go, but this technology will stay because it brings the texture of the materials to the level of the cells. Cells understand it, and they sit on the surface as if it were a natural matrix, and they can create new tissue on top of that. So it integrates the material. The versatility of the technology is tremendous because you can change the porosity of material, you can change its fiber size, you can use different types of materials, you can add new parts to the material. So it's so versatile that I'm pretty sure that this will be the technology for the future.